Of the grade 9 academic math course is linear systems, and this is the last section for this chapter, so there should be a test coming up soon. This is a fairly challenging topic we've got here, so let's just do it. Before moving on, we want to solve a linear system, and I guess you need to know what a linear system is, which is just, it means that you've got two or more, but we usually deal with two straight lines. Linear is straight, and the system means there's two or more than one anyway. The solution to a point of to a linear system is the point of intersection. Okay, so you got two straight lines, they run into each other. Where they cross, that's the point of intersection, and that's also the solution. Okay, and you'll see that on the next little grid I have there. The solution is right there. And different ways you can find the solution. I mean, obviously, if you just read it off the graph, you can do that. This particular one, though, I mean, if I tried to figure out what that was, that's what, 1 point, not quite 1.5, right? Under 1.5. I may have to estimate. And the great thing about algebra is you don't have to estimate. You can get exact numbers. So we're going to find points of intersection graphically, yes, which is nice, but we're also going to do it algebraically. And that's where the fun is. So just looking at this particular example, and again, I'm going to whip through it quickly. I expect you'll have to pause the tape, but that's all, I'm showing my age there. Anyway, so say you have the two lines listed here. Here's one line, here's the second, here's the first, right? Here's the second, and I want to graph them, and then identify the point of intersection, and then verify it algebraically. So basically I got to do it with algebra, which is this, okay, and I got to do it with the graph. So the first thing I'm going to do, though, because I can't graph this, I suppose I could, yeah, I can't graph this. I got to put it in this form, okay? So I rearranged, and I'm going to ask that you just do that on your own, but this equation, it's just another way you could write it. It's not a very useful equation. It's not standard form, it's just some messed up form. We're going to rewrite it so it looks like this. So you should do that on your own. Make sure you can see that y, that, and this are the exact same thing. Okay? And then so my two lines end up being this one and this one. Because these are equivalent, it's just that this is a form I can work with. Okay, so here I go. The first in the blue is the 2x minus 1. So minus 1 is the y-intercept, and then my slope is 2. So that slope of 2 means up 2 over 1. Up 2 over 1. You can see my graph's not perfect, but that's what it is. And this one here, y-intercept of minus 3, and it's the slope, so that's up 4 over 1. Up 4 over 1. Okay? And basically where they cross is my solution. And it looks not exactly like 1, 1, as when you graph, you never get a really exact. It looks like 1, 1, and I'm going to guess that's what it is. But I don't really know that it's 1, 1. Until I've gone through the process of the algebra, right? Because as I've shown you, my graph kind of goes off. It's hard to draw a perfect graph. You know that. And so algebra is a much nicer process, even though it's a bit painful. So here we go. So the idea, and this is a whole new thing you're learning here. The idea, let's look at the green first, is I can find the solution is where the x and y are equal for each equation. So how I do that is I take it in y equals mx plus b form, and I take the mx plus b for this one, I make it equal to the mx plus b for this one because my y's are equal at the solution point. Okay? And I solve for x. So let's just go through that far here. So see what I did? 2x minus 1, this part equals this part. And then I rearranged it. So first thing I did was I got all my x's onto the left by subtracting 4x from both sides. Right? And I ended up with minus 2x minus 1 equals minus 3. Right? So 2x minus 4x is minus 2. That's how I got that. Okay? And these 4x's cancel. Now I add 1 to both sides so I can get rid of this. I end up with minus 2x equals minus 3 plus 1, which is minus 2. Divide both sides by minus 2, and I end up with x equals 1. So that's my coordinate of my solution, which, by the way, looks about right. I expected it to be 1. There's my x coordinate of my solution based on the graph, and that's what I got here. Now, how I find the y-coordinate of the solution is just take, this is where I am here. So I know x now, x equals 1, and I'm going to sub the solve value into the first, it doesn't matter which, one of the equations. So I'm going to sub it into this one. And so I say y equals 2, I'm going to put, instead of x, I'm going to write 1 minus 1, which is 2 minus 1, which is just 1. So therefore my solution is that point, 1, 1. So I saw it on the graph and I verified it algebraically. Okay, so on your test I may ask you to do it graphically, I may ask you to do it algebraically. This is the strategy. Okay, here's a doozy of an example. Okay, so Ferd's walking to his cousin's place, okay, which is 12 kilometers north, I guess. Mine doesn't look like north and west, or north and east, but oh well, north and south. At the same time, his cousin starts to walk towards his house. This is Ferd's speed rate, and this is his cousin's rate. How far from Ferd's house will they meet? Well, Miss Stone made a mistake. We're going to say how far from Dreff's house because I based everything on that. And by the way, Ferd's cousin is Dreff. So just change it. Change it now. Okay? So because I said let x be the time since Ferd left his house and y be the distance from his cousin's house. So Ferd's equation, to find his equation, they both have an equation. We're going to find the solution. That's really what we're doing. And this is actually before you get into any writing. Let's just look. So here's Ferd. Here's 12 kilometers difference. Ferd's in his house. Dreff's in his house. Dreff starts walking this way. Okay? Ferd starts walking this way. And I'm saying the distance between Ferd and his house, we're looking at this distance here, is shrinking at a rate of 4 kilometers per hour. The distance between Dreff and his house is growing, right? Because he's moving away at 3 kilometers per hour. So this one's going to be negative because the distance between Ferd and this house is shrinking. Okay? And we know that the initial distance from Dreff's house is 12 kilometers. And Dreff's initial distance is 0 because he's at his house. So we're comparing everything to Dreff's house, which was where I made a mistake. But that's where we're going to solve the question. Okay? So Ferd's equation, the distance is shrinking, so the slope is negative. But it's his rate, it's his speed. The y-intercept is how far he is to begin, so now we have an equation. Okay? Dreff's equation is the distance from his own house is growing at a rate of 3 kilometers per hour, and he's starting right there, so his y-intercept is 0, so there's his equation. So we need to find the solution, the x, and x is time, the x for when they connect. Okay? Well, so what are we looking for? When will they meet? So this is the solution to this linear system. So we do the same thing as we did before. We find the excuse me, the point of intersection. Okay? So here's my first equation. Here's my second equation. I'm going to take the y's and equate them, right? And that means that minus 4x plus 12 equals 3x. When that's true is when they meet. So you just go through the process of solving, bring all the numbers to one side, bring all the x's to the other side. You end up with negative 7x equals negative 12. X equals 12 over 7, which works out to it's an approximate 1.7 hours. Okay? So we think of time, we don't really think of time as 12 over 7. It's about 1.7 or between 1 and 2 hours. Okay? So that's when they'll meet. So that's a tough question, and certainly, you know, you'll see some questions like this in your homework, and if you need some help, please ask me. But that's it for this note, and that's really it for this chapter. Oh, here's the graph, by the way. So if I was going to graph, here's Ferd's graph. Okay? Here's Dreff's graph. So Ferd's graph is starting at 12 and going towards Dreff's house at a rate of 4 kilometers per hour, so at a rate of negative 4, so down 4 over 1. Dreff, who's here in the purple or brown or whatever, is starting at home and going up by a rate of 3, so his slope is 3. So you can see the point of intersection right there, and you could read it off the graph. Just another way you could solve it. Okay, so whether you solve it using algebra, a question like this, where it doesn't ask you at all, you could solve it this way using algebra. You could solve it using the graph. Again, you want on the graph, you're kind of reading it going, well, what number is that? And you might guess 1.7. I put 1.7 because I knew that was the answer, but I might have guessed 1.8 if I just looked at it. Anyway, that's the question, that's the unit, and good luck with the homework questions.